All right, number 8. We just want to sketch the graph of the continuous function on 0, 4 that satisfies the given properties. So it doesn't look like we have to solve anything here. I'm going to make full screen. And so the properties we are looking for is that the derivative of the function is equal to 0 for x equals 1 and 2. So that tells us that there's a minimum or a maximum at 1 and or 2. So whenever the derivative is 0, that's going to tell us a horizontal tangent line giving us a maximum or minimum. So we have a minimum at 1 and 2. Minimum or maximum, don't know. But 1 and 2 give us a minimum and or maximum. Could be both minimums, both maximums, one of each. We have an absolute maximum at 4. The highest point of the graph occurs when x is 4. The absolute minimum occurs at 0. So the lowest point is 0, highest point is 4. And then we have two critical values, 1 and 2. It says f has a local minimum at 2. So we know that 2 is a minimum. 1 could be a minimum, but it could also be a maximum. All right, so continuous starts out. This is not continuous, so I would X this one out immediately. I'm going to start with the easiest points, 0 and 4. Minimum at 0, maximum at 4. So lowest point is at 0. Highest point is at 4. I will get rid of that. Lowest point 0, highest point 4, get rid of that one. The only one that could be it is D. Lowest point at 0, highest point at 4. If I zoom in a little bit on this graph, at x equals 1, that kind of looks like that hill, like a maximum. This looks like that little valley is going from decreasing to increasing. So at 1 and 2, we get those critical points. And then this is definitely a local minimum because it's kind of going down and then starts going up. This is going up and starts curving down. So we get a maximum at those two values, 1 and 2, that talked about being critical points. And we had our maximum and minimum at 0 and 4. So we could really answer this one just based on the absolute maximum and minimum because no other graph matched the maximum and minimum. All right, number 9, we're going to find the critical points of the following. So we will be required to write some things down. All right, so to find the derivative, we're going to use the power rule. So we're going to find f prime of x multiplied by 2. 2 times 2 is 4. And then subtract by 1. So that just gives us 4x. Take a 1, multiply by 1, so minus 3. Subtract 1, that'll be x to the 0, which is 1. And then derivative of a constant is 0. So here's our derivative. We're going to set that equal to 0. So 0 is equal to 4x minus 3. Add 3. 3 equals 4x. Divide by 4. It's supposed to be an equal sign. So we're going to get x equals 3 divided by 4. So this is going to be our critical point. Okay, 3 over 4 interior critical point. So that's the only one we get. Critical points of this function are 3 divided by 4.